Let's now work out two simple examples to illustrate the concepts that I discussed in the previous slide. So, example 1. Consider the following dynamical system. X dot is equal to x plus y. Y dot is equal to 3x minus y. So what we need to do is first find the nullines, then find the local flow in the segments, and then infer the local flow. So what are the nullines? X dot equals 0 gives us a nullline y is equal to minus x. And y dot equals 0 gives us a nullline y is equal to 3x. So let's look at these in the phase plane. So let's plot x, y, and let's first figure out where are the nullines. So the nullline x dot equals 0 is a line y equals minus x. So it's a line inclined at minus 45 degrees that goes to the origin. So this is nullline x dot equals 0. And we can infer the flow on either side of the nullline. We see that x dot equals 0 and x plus y equals 0. So if x plus y is a bit positive, which is to the upper right of the nullline, x dot is positive. And on the other side, x dot is negative. There's the other nullline, y is equal to 3x. So that's a line inclined at an angle tan theta is equal to 3. So this is the nullline y dot equals 0. And once again, we can easily infer the flow on either side of the nullline. It's up just to the right of the nullline, and it's down just to the left of the nullline. One other thing we can easily infer is that if we look what happens to the flow along the nullines itself. So along the x dot equals 0 nullline, the flow is vertical. And we see that the flow is vertical and up on the right side of the y dot equals 0 nullline. It's increasing linearly as I move further away. And similarly, the flow on the other side of the nullline is downward and getting larger as I move away. On the y dot equals 0 nullline, the flow is horizontal, and it's to the right as I move up and gets linearly larger. And similarly, on the other side, it's to the left. So now we're in a position to try and infer what the global flow looks like. So in the four segments defined by the intersection of these four lines, in the upper right segment, the flow is to the right and up. And in the other segments, we can infer the flow equally in the same way. Here, the flow is down and to the right. In this segment, the flow is down and to the left. And here, the flow is to the left and up. And so that is a global flow pattern. And so one sees that in two directions, the flow is towards the fixed point, and in the orthogonal two directions, the flow is away. This will define a saddle point, which I'll denote by this x. So that is the flow pattern for this example.